Hey everyone, in this section we're going to talk about linear equations in one variable. We'll start out by getting a feel for what kind of equations we're actually working with and the kind of outcomes we can expect. We describe an equation as linear if the variable that we are solving for has at most a power of 1. Usually for us that's going to be the variable x, but it also could be others. So a couple of examples. If I have 2x plus 3 equals 4x minus 7, and 3x minus 4y equals 7 minus z, these are all linear equations. Example 1 is an equation in one variable, whereas example 2 is a linear equation in several variables. If I were to solve for x in that second example, I would get a solution of x that is in terms of other variables like y or z. And depending on the problem that we're working on, that could be a possibility. But now for a couple of non-examples. Look at 3x squared plus 4x minus 1 equals to 0. That has an x squared term which does not cancel away, so that first one is not linear. Next I have a 5 times x times y plus y equals to 1. This one isn't linear because I have a 5 times an x times a y. I have a term with two variables being multiplied in the same place, and that is what disqualifies it from being linear. Next, let's talk about outcomes. The first outcome is known as an identity. If I take the equation 3x plus 2 plus 4x equals 3 plus 5x minus 1 plus 2x, I'll notice that both the right and the left-hand side simplify to 7x plus 2. So whenever the left and right-hand side turn out to be the exact same quantity, the equation is true for all real numbers x, and so we call it an identity equation. The next kind is one called a contradiction. Suppose I have the equation t plus 3 equals t. If I were to cancel those t's out on both sides, I would yield the statement 0 equals to 3, which is impossible. So a contradiction is an equation that has no solutions or is false for all real numbers, because no real number t is ever going to satisfy the equation t plus 3 equals to t. The last kind, and it's the most common kind that we'll encounter, is a conditional equation. The equation 2x plus 1 equals 3 is only true when x is equal to the number 1. So a conditional equation is an equation that is true for some or one real number, not necessarily all of them. Let's look at some other examples where we have to identify whether an equation is linear or not. 3x plus 2 equals 4x minus 1 is definitely linear. I only see one variable and it's raised to a power of 1. Next, let's look at number 2. X squared minus x squared plus 2x equals 2 minus 3x. Just because I see an x squared doesn't mean I automatically get to say it's not linear. What we'll see is that it actually cancels out. Go ahead and distribute that negative sign, and we'll get x squared minus 2x equals to 2 minus 3x. Therefore, those x squareds cancel out, and I'm left with negative 2x equals 2 minus 3x. So this is a linear equation because those nonlinear terms cancel out. Next, take a look at x cubed minus 4x equals to 1. That x cubed does not cancel with anything, so this is a case where a nonlinear term, namely one that doesn't cancel, says I do not have a linear equation. To solve linear equations, we essentially have two rules. The first is additive cancellation, which says that I'm allowed to add or subtract the same term from both sides. So take the equation 4x minus 5 equals 2x minus 3. If I want to get that negative 5 to the right-hand side, I can add a 5 to both sides. This will give me 4x equal to 2x plus 8. Basically, if I have a level scale and I add 5 pounds to both sides, I end up with a level scale. And that's the whole point of equation solving, is keeping your equation balanced. Similar to this, I can also use a multiplication cancellation law. It says I'm allowed to multiply or divide both sides by the same term. So take the equation x plus 2 over 3 equals x minus 1. And by the way, this is linear. Even though I have a fraction, the only thing in the denominator is a number, not a variable. But say you're trying to solve for x and you're not overly thrilled that a division of 3 is there. The multiplicative cancellation law says that I can multiply both sides by a 3. That way that 3 cancels out on the left-hand side and just stacks up on the right-hand side. I end up with the equation x plus 2 equals to 3x minus 3. In this next slide, we'll solve for x for the equation 3 times x minus 2 plus 7x equals 1 minus 2 times x minus 1/2. We have the variable x showing up all over the place, but the point is to isolate it on one side of the equation. The first thing I'm going to do is start simplifying. Thinking about my order of operations, I have a 3 I can distribute on the left and a -2 I can distribute on the right. And once I perform that action, I'll end up with 3x minus 6 plus 7x equals 1 minus 2x plus 1. Let me combine like terms on the left and right hand side, which will get me 10x minus 6 equals -2x plus 2. Now here's where I can start trying to isolate the variable x. Let me get all my variables of x on one side of the equation. So I'm going to start by adding a 2x to both sides so that it cancels on the right hand side. This will result in the equation 12x minus 6 equals to 2. Now that all x's are on one side, I can get all of my constants on the other side. So I'm going to add a 6 to both sides so that it cancels on the left. So I have 12 times x is equal to 8. My last step will be to divide both sides by 12. This gives me an answer of x equals to 8 divided by 12, which as a fraction reduces to x equals to 2 over 3. Therefore, the solution set of this equation is x equals 2 over 3. For our next example, consider the equation 7x minus 5 over 4 plus 14 over 8 equals to 14x plus 4 divided by 8. It is not always the case that I need to find common denominators so that I can combine fractions. In this case, there's actually a nice way around that. What I'm going to do is actually multiply all sides of the equation by the number 8, because I see a lot of denominators of 8, or the denominator of 4, which is the divisor of 8. So by multiplying all sides by 8, which we'll do now, on the left-hand side we're going to distribute, and on the right-hand side we'll see those 8's cancel. Now I just need to simplify the right-hand side. That 8 over 4 is going to become a 2. That 8 times 14 over 8 gives us a cancellation. So speaking on this generally, what I have done is I have multiplied all sides by the least common multiple of all of the denominators. That pretty much guarantees me that I'm going to clear every fraction in sight, namely numeric fractions, and I'll just have some numbers that stack up in the numerators, which I can distribute. Overall, that's a much better strategy than trying to add fractions together by finding common denominators. Next, I'm going to distribute that 2 and then simplify the left and the right hand side by combining any like terms I see. But I notice that the left and right hand side are the exact same value. This is an identity equation. It means that it is true for all real numbers x. In the next example, we're going to solve for y in the equation 2.8y plus 1.2 equals 3.2y. Now the annoying thing about this equation is that I have decimal numbers. But there's a nice workaround. Every decimal place is in the exact same position. So thinking back to our video on scientific notation, all I have to do is multiply both sides by a factor of 10. That factor of 10 will move every decimal place over by 1, giving me whole integer numbers and not decimal numbers. So performing this action and distributing the 10 on both sides will give me the equation 28y plus 12 equals to 32y. This was not a necessary step. I could have worked with the decimals if I wanted to, and I would have gotten the same answer. This is just a matter of making our equation a little bit more elegant and user-friendly. Next, we'll go ahead and isolate the y variable by subtracting the 28y from both sides. This gives me 12 equals to 4y, so now I can divide both sides by 4. And I'm going to choose to write my answer as y minus 3 as opposed to 3 minus y. It's conventional that the variable you're solving for expressed in the solution is written on the left. Therefore, the solution set to this equation is y equals to 3. For our last example, let's look at an equation that has several variables that aren't all linear. We're going to look at the equation s equals to 2 pi r squared plus 2 pi r h, and we're going to solve for h. Even though I have an r squared and a pi, I can still solve for h because h itself is a linear variable. It just means that my solution is going to have h expressed in terms of other variables. So let's write this equation out in the middle of the page. And we're going to start trying to solve for this by getting every term with an h in it on its own side of the equation. To do this, I can take that 2 pi r squared and I can subtract it from both sides. And then I'm going to rewrite this as 2 pi rh equals to s minus 2 pi r squared. Now let me isolate my h variable so that it's written out front. This makes it a little bit easier to see, because now I realize that I can divide both sides by the remainder of those terms, which is 2 pi r. This gives me a final answer of h equals to s minus 2 pi r squared divided by 2 pi r.